All right, let's solve this inequality. So to solve the inequality, the first thing to do is to move all of these things to the other side, and that's just basic algebra. So I have to subtract 9x to get the 9x over from both sides. And I have to, if that's being subtracted, how do I get?
You gotta add it.
So add it. So my new equation is going to be x cubed minus x squared minus 9x plus 9 is greater than 0. Now this problem is a little bit trickier. Remember what we're trying to do here, graphically speaking, this is going to be some sort of inequality. This is going to be some sort of cubic equation. And so somehow, somewhere, it's going to be going, since it's a cubic and it's a positive leading coefficient, it's going down on the left and up on the right. And there's up to 3 zeros. We don't know exactly how many, but there could be as many as 3 places where it crosses the x-axis. So it's going to go, so it might do this. That might be what it does. Or it might bounce off of one of them. It might do something like this and bounce and then go through, right? Or it might go through only once, because it could bounce underneath it and actually not touch it, right? So we don't really know what it's like. So what we have to do is solve this equation.
All right.
We have to solve this, and the way to solve this, have you learned yet how to do synthetic division? Have you learned about the Q over R? All right, so depends on what you've learned so far, but probably you have learned how to factor by grouping. And if you see this right here, you're probably thinking, wait a minute, there looks like I can take a 9 out of that, and I can take an x squared out of that. That's exactly what we're going to try. So let's take an x squared out of these first two.
So it's
X minus 1. And let's take a negative 9 out of these two. Now the reason I had to take a negative 9 is because I see that's a negative there. So I want that to be a negative. So when I take a negative 9 out, I'm left with
9, x minus 9.
X minus 9, good. You get that?
Yep.
And so then how do these factor now? What can come out of each of those terms?
Possible.
Uh-oh, I said x minus 9, not x minus 9.
X minus 1.
Fortunately, yeah, because it was x minus 9, it wouldn't work. It's x minus 1. And so you can see now that there's an x minus 1 and an x minus 1. So I can take x minus 1 out.
Yep.
And then what's left in here?
It's x squared minus 9.
Good. And if I have x squared minus 9, do you recognize how that factors?
Yep.
Into what? Plus 3, minus 3. And so what are my 3 zeros?
Positive 3, negative 3, and positive
1. And I don't even really need to do my sign analysis, right? Because if I look at my graph and I know what's going to happen, this means 1, negative 3, and positive 3 are my 3 zeros. So here's negative 3, here's 1, and here's positive 3. And remember, I always said it has to go down to the left and up to the right?
Yep.
So it has to do that.
Yeah.
There's no other real option. So where is it greater than 0?
It's greater than 0.
Notice not equal to, but greater than?
It's greater than 0 when it's greater than negative 3, but less than 1. And when it's greater than negative.
That's right. So here and there.
Yep.
So then we just write that out. So x has to be between, and not including, between negative 3 and positive 1, or greater than positive 3. So there's a couple ways you can write that answer. Depends on how they want you to write it.
Okay.
So that's one way you could write it. Another way you could write it is with interval notation. You familiar with that? I don't know how your teacher wants you to do it, but you would write like this: union 3 to infinity. That's probably how they want you to do it. So that's how you would write it. X is an element of negative 3 to 1, union 3 to infinity.